Hello friends, I am Dr. Sudhan Sharma from School of Computers and Information Sciences, Indira Gandhi National Open University. And today's session is about integration 1. This is in continuation of our past session. In our last session, we discussed about what integration is, what do we mean by antiderivative and how antiderivative and integration are synonymous. Apart from this, we learned about the fundamental formulas of integration, and now we are going to extend our discussion on integration by going into more details. In this session, we are going to discuss about how integration by substitution is performed, how to perform integration of the rational function. Apart from this, what do we mean by integration by parts? So let's start. The objectives of today's session are that after going through this session, you should be able to perform integration by substitution, perform integration of rational functions, and perform integration by parts. Now, what do we mean by integration by substitution? Now, if the integrand is of the form fx, if integrand is of the form integral of f functioning gx into g dash x dx, then we can integrate by substituting gx is equal to t, by substituting t for the function gx. Now, in order to understand this concept, let me give you some illustration. Let there be a function e to the power x into e to the power x plus 2 to the power 7. Now, looking at this function, if we say that this is, say we substitute x to the power 7 or say t to the power 7, that means we are substituting t is equal to e to the power x plus 2. So, that means the function f t is t to the power 7 or f of g x it is, which is equal to e to the power x plus 2 whole to the power 7. Now, taking the derivative of gx, now what is gx? Gx is e to the power x plus 2. Now, derivative of gx, g dash x will turn out to be e to the power x. Now, looking into the expression which is just given over here, that is integral of f of gx into g dash x. Now, what will be f of gx? F of gx is nothing but e to the power x plus 2 to the power 7. So, integral of f of gx into g dash x dx, that will turn out to be integral of e to the power x plus 2 to the power 7 into e to the power x dx. So, that means we can say that this is nothing but you can say that integral of e to the power x into e to the power x plus 2 to the power 7 dx, which is nothing but this, is can be written in the form t to the power 7 into dt. So, that means we had simplified the complex integral which was given over here, that is e to the power x plus 2 to the power 7 into e to the power x dx, just by replacing e to the power x plus 2 by t. Replacing e to the power x plus 2 by t, we got dt is equal to e to the power x. So, it is simplified to this, and now we can simply apply the formula integral of x to the power n dx is equal to x to the power n plus 1 over n plus 1. So, applying the formula, you can get t to the power 8 in t to the power 8 upon 8 plus constant of integration this. This will replacing t by its equivalent expression. What we are going to get? We are going to get e to the power x plus 2 whole to the power 8 divided by 8 plus c, which is this. So, by using this technique, by using the technique of substitution, you can simplify the complex integral into its simpler equivalents. To understand this into more details, we are going to solve some more numericals so that you are going to have a better grasp on this topic. Now, over here, say the integral given, we are supposed to integrate integral of 7x minus 2 into dx. Now substituting 7x minus 2 say equal to t square. Okay. Then what we are going to get, differentiating both the sides, you will be getting 7 dx is equal to 2t dt. So that means dx is nothing but 2 by 7 into t dt. So replacing dx in this expression by this value, and 7x by t square in this equation, what you are going to get, integral of square root of t square into 2 by 7 t dt, which will be turning out to be integral of t into 2 by 7 t dt, that is equal to 2 by 7 integral of t square dt. Again, applying the same formula, integral of x to the power n dx is equal to x to the power n plus 1 over n plus 1 into this expression, you will get integral of t square dt, which is equal to 2 by 7 t cube by 3 plus constant of integration. So, this will solve to 2 by 7, 2 by 21 t cube plus c. Substituting the value of t, you will get the answer 2 by 21 into 7x minus 2 to the power 3 by 2 plus c. So, why it is turning out to be 3 by 2? Because t is equal to square root of 7x minus 2. So, that means t is equal to 7x minus 2 whole to the power 1 by 2. So, that means t cube is equal to 7x minus 2 whole to the power 3 by 2. So, that is why we are getting the value 2 by 21, 7x minus 2 to the power 3 by 2 plus constant of integration c. I hope you understood how we solve this integral. Again, one more example over here, we are supposed to evaluate the integral I is equal to integral of dx upon 3x minus 2 square. So, again the same technique, substitute 3x minus 2 by the value say t. Differentiate both the sides. So, differentiating both the sides, you will get 3x is equal to dt. Substituting the value of t and dt, say equation 1 and equation 2 in this equation, say equation A, what you are going to get? You are going to get integral I is equal to 1 by 3 dt upon t square. Okay. So, this will turn out to be 1 by 3 into t to the power minus 2 dt, which will again solve to by applying the same formula, x to the power n dx is equal to x to the power n plus 1 over n plus 1. Substituting this formula, using this formula in equation number 3, you will get I is equal to 1 by 3 t to the power minus 2 plus 1 upon minus 2 plus 1 plus constant of integration. This will turn out to be minus 1 by 3 into t to the power minus 1 plus c. So, that means minus 1 by 3 t plus c. So, what substituting the value of t from equation number 1, you will get the expression I is equal to minus 1 upon 3 into 3x minus 2 plus c, which is the required answer. So, over here just ignore this integral, and this is the correct answer. So, again let me solve one more numerical for you for better understanding. This appears to be bit complicated, but it is again very simple question if we try to solve it by the technique of integration by substitution. Over here we are given an integration, say A, equation A represents the integration. Now, over here the observation is that we can substitute this by f of gx. Now, what is gx over here? Gx is nothing but f of gx is say x to the power 4 or gx to the power 4. And what is gx? Gx is equal to x into e to the power x plus 3. So, that means we need to substitute x into e to the power x plus 3 by some value, say t. So, x into e to the power x plus 3 by substituting it by equivalent of t and differentiating so as to get the value of dx. So, applying the product rule. So, ddx of x into e to the power x plus 3 is equal to dt. So, that means ddx of x into e to the power x plus ddx of 3. This will turn out to be 0 is equal to dt. Now, applying the product rule to this, first one as it is derivative of second plus second one as it is derivative of first plus 0 is equal to dt. So, this will equal to 1 because ddx we are using the formula ddx of x to the power n is equal to n x to the power n minus 1. So, ddx of x will turn out to be 1 into x to the power 1 minus 1, that is 1 into x to the power 0, that is 1. So, this is how we got this expression as 1. So, this will solve to only 1, and derivative of e to the power x ddx of e to the power x is nothing but e to the power x. So, this will turn out to be e to the power x and this will turn out to be 1. So, entire answer is x into the e to the power x plus e to the power x into dx is equal to dt. So, that means x plus 1 into e to the power x dx is equal to dt. Now, using this, so we got this as equation number 1 and say this as equation number 2. Now, using this equation 1 and 2 in equation number A, what we are going to get? I hope you understood how we derived this equation number 2. Now, let us apply equation number 1 and 2 into equation number A, and what we are going to get is this. So, integral of x plus 1 e to the power x into x plus e to the power x plus 3 whole to the power 4 dx will resolve to, because this entire expression is nothing but your dt. And what is this expression? This is t to the power 4. So, entire expression get resolved to t to the power 4 into dt. Applying the simple formula integral of x to the power n dx is equal to x to the power n plus 1 over n plus 1 into this expression, you will get integral of you will get t to the power 5 upon 5 plus c as constant of integration. Substituting the value of t, so we get x into e to the power x plus 3 to the power 5 divided by 5 plus c. So, this is the answer of the overall integration shown over here. I hope you understood how to perform the integration by substitution. Now, next important topic over here is integration of a rational function. So, we are supposed to understand firstly what rational functions are and what are the types of the rational functions and how to handle each type of rational function. So, if say we are having a function Rx which is of the form Px by Qx, that means I want to say that Rx is equal to Px by Qx, where both Px and Qx are polynomials in x. So, for instance, we are having an example, say x minus 3 upon x square plus 1. So, Rx is equal to x minus 3 upon x square plus 1. That means Px is equal to x minus 3, which is a function in x, and Qx is equal to x square plus 1. Or we may have another function, say 2x plus 1 upon x square minus 3x plus 1. These are the rational functions. Now, the rational functions might be proper and might not be proper, or that means they mean improper. So, they are improper and proper. So, proper rational functions are those wherein degree of polynomial in numerator is less than polynomial in denominator, and improper rational function is where degree of the polynomial in numerator is greater than equal to degree of polynomial in denominator. Likewise, over here we are having this function, the degree of x minus 3, that is degree of x minus 3 is less than x square plus 1. So, degree of px is less than degree of qx, because degree of px is less than degree of qx. So, the polynomial x minus 3 upon x square plus 1 is a proper rational function. So, if the rational function is improper, may we say x square minus 1 upon x plus 1. Now, degree of the polynomial in numerator is greater than polynomial in denominator. So, that means this is an improper polynomial. In case the rational function is improper, wherein the degree of px is greater than degree of qx, in that case we are supposed to deal the rational function, we are supposed to rewrite the rational function Rx in the form that it is Ax plus Bx upon Qx, where Ax is a polynomial and Bx upon Qx is a proper rational function, that is the degree of Bx is less than degree of Qx. So, we need to rewrite the rational functions in a manner that it appears to be a sum of polynomial and a proper rational function. What we mean actually, we are going to understand when we are going to solve some numericals. The illustrations are given over here. So, let us first deal with what are partial fractions. We need to understand some of the important terms and terminologies before attempting this technique. So, in order to understand what is partial fraction, say let me give you an illustration wherein we are given say two fractions 2 upon 2x minus 3 and 1 upon 1 minus x. Now, if we add these two, so what we are going to get, just taking the LCM. So, you are going to get 2x minus 3 into 1 minus x. So, you will get, solving it, you will get 2 into 1 minus x plus 1 into 2x minus 3. So, opening the braces, you will get 2 minus 2x plus 2x minus 3 upon 2x minus 3 into 1 minus x. So, this will cancel out and 2 minus 3 is minus 1. So, minus 1 upon 2x minus 3 into 1 minus x, this is what there is. So, we can say that if this is the rational function, now for rational function minus 1 upon 2x minus 3 into 1 minus x, these two, that is 2 upon x minus 3 and 1 minus x are the partial fractions of this rational function. So, you can say that we can call 2 upon x minus 3 and 1 upon 1 minus x as partial fractions of minus 1 upon 2x minus 3 into 1 minus x. I hope you understand what we mean by partial fractions, but more clarity will be there when we are going to solve the numericals. But for the sake of understanding, just understand these two are the partial fractions and what partial fractions are. So, now how we split a rational function into partial fractions. Likewise, we learned that if the rational function is improper, then we need to split the rational function Rx into the form Ax plus Bx upon Qx. In our previous slides, we learned about this. Now, we are going to take this expression for different cases, and the very first case is when denominator consists of distinct linear factors. Now, over here there is an illustration wherein the rational function given to us is x upon 2x minus 1 into x plus 1 into x minus 2. Now, all the factors are distinct. there might be a situation we are going to see in our other slide, say x minus 2 into x plus 1 square. So, in this case the partial functions, partial fraction linear factors are not distinct. You are having x plus 1 as one factor and x plus 1 square as another factor. How to deal with that, those type of cases we are going to understand at that very situation. In this case, we are supposed to firstly understand how to express this rational function into partial fractions. So, in order to express this rational function into partial fraction, we take some three unknowns a, b and c, and we write the expressions as independent components are written in the denominator 2x minus 1 upon x plus 1 upon x minus 2. So, now we are supposed to find the values of a, b and c such that a, b and a upon 2x minus 1, b upon x plus 1 and c upon x minus 2 are functioning as partial fractions to the given rational function. Now, in order to find the values of a, b, c, let us first evaluate the right hand side of this expression, that is equation given above, say equation number 1. So, you can say x upon 2x minus 1 into x plus 1 into x minus 2. Taking the LCM of the right hand side, you will get 2x minus 1 into x plus 1 into x minus 2. So, it will be solving to x plus 1 into x minus 2 plus b into 2x minus 1 into x minus 2. Similarly, we are going to have part C, that means plus c into 2x minus 1 into x plus 1 whole divided by this. So, from left hand side and right hand side the denominator portion will be cancelled out, and what we are going to get is x is equal to a into x plus 1 into x minus 2 plus b into 2x minus 1 into x minus 2 plus c into 2x minus 1 into x plus 1. So, this is the equation which we are going to get. Now, the mechanism to get it solved is for what values of x the right hand side components will be vanishing, will turn out to be 0. So, by looking at these two components, we can find that if x is equal to minus 1, then this component will be 0 and this component will be 0, as a result of which only b will be existing. So, if x is equal to 2, if we substitute x is equal to 2 in this equation, in this section, then this will turn out to be 0 and this will also turn out to be 0. So, a section part A and part B will cancel out and only C will be existing. And similarly, if we substitute x is equal to 1 by 2, substituting x is equal to 1 by 2, you will find that the components only C will be varying. So, so you can use this concept to solve and find the values of A, B and C. So, let us find the value of A, B and C. So, for what values the entire expression will turn out to be 0, and how to use the coefficients to solve such expressions. Let me do it. So, substituting the value x is equal to 1 by 2, minus 1 and 2. So, let us firstly substitute the value x is equal to 1 by 2 in the expression, say this, that is a into x plus 1 into x plus minus 2 plus b into 2x minus 1 into x minus 2 plus c into 2x minus 1 into x plus 1. Substituting x is equal to 1 by 2 in this expression, that is equation number 1, you will get 1 by 2 equal to a into substituting 1 by 2. So, 1 plus 1 by 2 is 3 by 2 and 1 by 2 minus 2 is your minus 3 by 2. So, this turns out to be minus 3 by 2 and this turns out to be 3 by 2. Remaining all the values, substituting value 1 by 2 over here. So, 2 into 1 by 2, 2 will cancel out and minus 1. So, this turns out to be 0. Similarly, this 2x minus 1 substituting to 1 by 2, 2 into 1 by 2 minus 1. So, this turns out to be 0. So, entire this expression for B and expression for C will vanish out, and what we are remain with is A into 3 by 2 into minus of 3 by 2. So, that means you can say that by solving, A turns out to be minus of 2 by 9. 3, 3 the 9. So, that means A is equal to minus 9 upon 4, and solving it you will get A is equal to minus 2 by 9. So, first value turns out to be A is equal to minus 2 by 9. Similarly, by substituting x is equal to for the next value, that is your minus 1 in same equation, that is equation number 1. In equation number 1 which is given to us is this is the equation, substituting value minus 1 for value x, x is equal to minus 1 in this equation. So, first expression will turn out to be 0, minus 1 plus 1 is equal to 0, and last expression will again turn out to be 0 because minus 1 plus 1 is equal to 0. So, what we are remain with is value for B. So, B into 2 into minus 1 plus minus 1 minus 2. So, that means this turns out to be minus 1 is equal to B into minus 3 into minus 3. So, that turns out to be B is equal to you will get minus 2 minus 1 3 minus 2 minus 3 1 3. So, B is equal to minus 1 upon 9 because 3 3 the 9. So, minus minus plus. So, B is equal to minus 1 by 9. So, we got A is equal to minus 2 by 9, B is equal to minus 1 by 9. So, now again substituting x is equal to 2 in equation number 1, substituting x equal to 2 in equation number 1, some of the factors will turn out to be 0. See, let us see what are those factors. In equation number 1, substituting x is equal to 2, this will turn out to be 0, substituting x equal to 2 again, this will turn out to be 0. So, component of A and B will vanish out, and we are only remaining with C component. So, substituting value 2, C into 2 minus 1 into 2 plus 1. So, this will turn out to be 2 is equal to C into 3 into 3. So, this will turn out C is equal to 2 by 9. So, we got all the 3 factors, 3 variables A, B and C, and now by substituting them into the expression which we had earlier written, say this is the expression star, substituting A, B and C in star, you are going to have the equivalent expression which is this. So, this is the value of A, this is the value of B and this is the value of C. So, star equation number star will be simplified to this, and now you can simply apply normal integration rule by integrating this expression. Instead of integrating this, which will turn out to be very complex because opening the braces in the denominator, this will turn out to be a cubic equation and again it will be complicated. So, it is resolved to the right hand side, simplified to this expression, and integration of this expression is quite simple. So, we had gone through case number 1. Now, we are going to solve again the case number 2, wherein the denominator consists of repeated linear factors. So, this is the case wherein we are having the repeated linear factor. One linear factor is x plus 1 and other one is x plus 1 square. So, you can write the right hand side of this expression, that is x upon x plus 1 x minus 1 into x plus 1 square as a upon x minus 1 plus b upon x plus 1 plus c upon x plus 1 square. So, this is to be noted carefully because x plus 1 square is a repeated linear factor. So, that is why the right hand side is written in this format. Now again solving, taking the LCM and getting the expression, you will get x minus 1 into x plus 1 square. So a into x plus 1 square plus b into x minus 1 into x plus 1 plus c into x minus 1, and left hand side is this up into x minus 1 into x plus 1 square. So the denominator will cancel out and you are going to have the expression x is equal to a into x plus 1 square plus b into x minus 1 into x plus 1 plus c into x minus 1. So this is what we are going to get as equation number 1 in this case, and now we are going to solve for a, b and c. So how we are going to solve for a, b and c? Let's see. Okay. So we are going to have this expression, we derived this expression. Now again same strategy, for what values the component will turn out to be 0. So if we substitute x is equal to 1, looking at these values, for x is equal to 1, this expression will turn out to be 0, and for x is equal to minus 1, this expression will turn out to be 0, and this will also turn out to be 0. So we are supposed to find the values of x for which the expression is turning out to be 0. Thereafter, we might require to compare the coefficients from left hand side and right hand side. But to begin with, we are having values for which the expression components are turning out to be 0 in equation number 1, and the values are x is equal to 1 and x is equal to minus 1, which are written over here. Now, let us first take the value x is equal to 1, substituting x is equal to 1. We are going in this equation number 1. So, we are going to get a into 1 plus 1 square plus b into 1 minus 1 into 1 plus 1 plus c into 1 minus 1. So, component for b and c will vanish out and you are going to get 1 is equal to 4 times of a, and this implies a is equal to 1 by 4. So, we got the first component a. Similarly, we are going to get the other components by substituting the value of x as minus 1. So, by substituting the value x equal to minus 1 in equation number 1, we are going to get minus 1 is equal to a into minus 1 plus 1 square plus b into minus 1 into minus 1 plus 1 plus c into minus 1 minus 1. So, this will turn out to be 0 and this will turn out to 0. So, a and b components will vanish out and you will get minus 1 is equal to minus 2c. That means c is equal to 1 by 2. So, we got component a and we got component c. But what about the component b? Now, in order to get the component b, you are supposed to look at equation number 1 in a different way. The mechanism is, if we expand equation number 1, what we are going to get, x is equal to a into x plus 1 square is a square plus b square plus 2ab, and second component for this you are going to get x square minus 1 square plus c into x minus 1. So, that means if we compare the coefficients of the left hand side with the right hand side, the left hand side is only having the coefficients as 0 x square plus 1 x plus 0 is equal to, you can say, a plus b x square plus a minus b plus 2ax plus c into x minus 1. So, you are seeing that the coefficient of x square can be compared, and by comparing the coefficient of x square of left hand side and right hand side, you are getting a plus b equal to 0. That means a is equal to minus of b is equal to minus of a, rather you can say b is equal to minus of a, because we are here to evaluate for b. So, that means b is equal to minus of 1 by 4. So, you got the answer for a is equal to 1 by 4, b is equal to minus 1 by 4 and c is equal to 1 by 2. Now, substituting for a, that is 1 by 4 in this expression, b, that is minus 1 by 4 in this expression, and c is equal to 1 by 2, then this right hand side is actually simplified. This left hand side is simplified to the right hand side, and now you can simply apply the technique of, say, substitution or normal integration to solve this integration. So, I hope you understood case number 2. Now, let us extend our discussion to case number 3. In case number 3, the denominator is composed of an irreducible quadratic equation. Likewise, over here it is written in the form x upon x plus 1 into x square plus x plus 1, which is irreducible. So, that is why we can express this expression as a upon x plus 1 plus bx plus c upon x square plus x plus 1. So, we decompose the expression into this format, which is given over here. Now, applying the same strategy, we are having on the left hand side, the expression is x into x plus 1 into x square plus x plus 1, and taking the LCM of the right hand side, you will be getting x plus 1 into x square plus x plus 1, a into x square plus x plus 1 plus bx plus c into x plus 1. So, this is equal to x up x plus 1 into x square plus x plus 1. So, the denominator part will cancel out, and now we are having the expression a is x is equal to a into x square plus x plus 1 plus bx plus c into x plus 1. Now, solving for a, b and c, as we did it in our earlier session, we will get the values of a, b and c as b is equal to 1, and we are going to get a is equal to minus 1 and c is equal to 1. So, in order to understand this, how we got the values for a, b and c, let me solve it for you. So, if we substitute for this, we are going to get, say, for x is equal to minus 1, this is going to be one of the factors for this equation written over here, which we had determined, but after taking the LCM of this expression and solving it for x. Then for x is equal to minus 1, what we are going to get, say this is equation number 1, substituting x equal to minus 1, you will get minus 1 is equal to a into minus 1 square plus minus 1 plus 1 plus bx plus c minus 1 plus 1. So, this will turn out to be 0, and this both of them will also be cancelled out. So, that means a is equal to minus 1, because minus 1 square is nothing but 1. So, first value we get a is equal to minus 1. Now, how to determine value for b and c? Now, again expanding the expression, this you will get, to determine the value of b and c, we are supposed to compare the coefficients of x square. So, on comparing the coefficients of x square, in equation number 1, you can say x is equal to ax square plus ax plus a is equal to plus bx square plus bx plus cx plus c. So, you can say it is a plus b x square plus a plus b plus c x plus a plus c. So, this is simplified. Now, comparing the coefficients from left hand side, you can say that you can rewrite left hand side and right hand side at this. Now, comparing the coefficient of x square and comparing the constant terms, you are going to get two equations, that is a plus b is equal to 0 and a plus c is equal to 0. So, this implies b turns out to be minus of a and c also turns out to be minus of a, and we had already determined a is equal to minus 1. So, this means b is equal to 1 and c is also equal to 1. So, substituting the value of a, b and c at their respective position in this equation, we are going to get the expression x upon x plus 1 into x square plus x plus 1 can be rewritten as minus 1 upon x plus 1 plus x plus 1 upon x square plus x plus 1, which is our this equation, and integrating this is much simpler in comparison to this equation. So, we learned what is the method of splitting of the rational function into partial fractions, and we had discussed all the three cases, and we understood how to simplify the given expressions. Now, let us extend our discussion by solving some numericals. Over here, one question is given to you. We are supposed to integrate x upon x plus 1 into 2x minus 1. Now, this can be rewritten integral expression x upon x plus 1 into 2x minus 1 can be rewritten in the form a upon x plus 1 plus b upon 2x minus 1. Likewise, it is written over here. Now, again adopting the same strategy, we got the expression x is equal to a into 2x minus 1 plus b into x plus 1. And now, for what values of x this will be 0? For 1 it should be 1 by 2, which is this value, and if we substitute x equal to minus 1, that is this value, the expression will turn out to be 0 for a and b respectively. Now, taking value x is equal to 1 by 2 in this equation number 1, it will be rewritten as 1 by 2 is equal to a into 2 into 1 by 2 minus 1 plus b into 1 by 2 plus 1. So, this will cancel out, and as a result of it, this component will be 0. So, you can get 1 by 2 into b into 3 by 2. So, that will turn out b is equal to 1 by 3. Now, similarly, for x is equal to minus 1, in this equation number 1 will be simplified to a into 2 into minus 1 plus b into minus 1 plus 1. As a result of which, this component will turn out to be 0. You will be getting a is minus 1 equal to a into minus 3. This implies a is equal to 1 by 3. So, you got a is equal to 1 by 3 and b also equal to 1 by 3. Substituting a and b in this equation number in the simplified form, you can rewrite the given integral. You can rewrite the given integral into the format, into this format, and let us integrate it now, and you will understand what is the benefit of using this technique. So, that means you can rewrite this integral as integral of a upon 1 plus x plus 1 dx plus integral of b dx upon 2x minus 1, which was written in the form of the partial fraction. Now, substituting the value of a as 1 by 3 and also the value of b as 1 by 3, you can rewrite this integral as 1 by 3 into integral of dx upon x plus 1 plus 1 by 3 into integral of dx upon 2x minus 1. Now, let us integrate it, multiplying and dividing this component by 2 So 2 into this. Why we are doing it by this? Because we know integral of f dash x by fx dx is nothing but log of fx, log of fx. So we are using this formula. So in order to apply this formula, we need to derivative of 2x minus 1. If this is fx, then f dash x, will be equal to 2. So in numerator and denominator, there is no presence of 2 in this component. In this component, there is no presence of 2. So we multiplied and divide by the factor 2. So multiplying and dividing by factor 2, it will not change this expression. So but the integral will be simplified to the form f dash x upon fx. So you can now write this expression and this expression as 1 by 3 log of x plus 1 plus 3 into 2 is 6. So 1 by 6 log of 2x minus 1 plus c. So this is your integral. So we simplified, we learned how to apply the concept of partial fraction, simplify, determine the constants a and b, using those constants into integral, and then we had used the formula f dash x by fx dx is equal to log of fx, which in our case is the fx is x plus 1 and 2x minus 1. So that's why the answer turns out to be 1 over 3 log x plus 1 plus 1 over 6 log of 2x minus 1. I hope you understood how we solve this numerical. Now let's solve some more numericals. In our earlier session, when we were dealing with the integration, in our past session, we learned about two formulas, and those two formulas are this 1 and 2, that is dx upon x square minus a square is equal to 1 over 2a log x plus a upon x minus a plus c. And second one was dx upon a square minus x square is equal to 1 over 2a log a plus x upon a minus x plus c. But we just understood that these are the formulas, but now we apply the concept of partial fraction to understand how these formulas were determined. So let's apply the understanding of partial fraction to solve this first expression, that is 1 upon x square minus a square. So 1 upon x square minus a square can always be written as 1 upon x minus a into x plus a, because we know the identity a square minus b square is equal to a plus b into a minus b. So using this identity, we can write x square minus a square, we can write this identity x square minus a square as 1 upon x minus a upon x plus a. Now expressing this into the terms of the partial fractions, you can always write 1 upon x minus a into x plus a as equal to a upon x minus a plus b upon x plus a. Now solving, as we had already done, that we took the LCM, cancel the denominator part, and equating the coefficients, you will get the expression equation number 1, which is 1 equal to a into x plus a plus b into x minus a. Now for what values of x the components a and b will vanish? For value x is equal to a, the component b will vanish, and for value x is equal to minus a, the component a will vanish. So substituting value x is equal to a and minus a separately, you will get that. So substituting x is equal to a and minus a in equation number 1, you will get 1 is equal to a into 2a, that means a is equal to 1 upon 2a. Similarly, substituting a is equal to minus a in equation number 1, you will get 1 is equal to b into minus 2a, that means b is equal to 1 upon minus 2a. Now substituting value of a is equal to 1 upon 2a and b is equal to minus 1 upon 2a in equation number 1, the partial fractions can be rewritten as integral of dx upon x square minus a square is equal to 1 over 2a 1 upon x plus a minus 1 upon x minus a. Now again we are using the same identity, integral of f dash x upon fx into dx is nothing but log of fx. So that means integral of this will turn out to be log of x plus a, and integral of this will turn out to be log of x minus a. And we also know that log of a minus log of b is nothing but equal to log of a by b. So that means we are having log of this minus log of this. So this will be simplified to log of x plus a upon x minus a. So the entire expression after integration using partial fraction, you will find that dx upon x square minus a square is equal to 1 over 2a log of x plus a upon x minus a plus c. Similarly, you can go for the other part, that is dx upon a square minus x square is equal to 1 over 2a into log of a plus x upon a minus x plus c. Now, let's extend our discussion by solving one more numerical, wherein we are supposed to integrate x upon x minus 1, x plus 5 to x minus 1. This is, we can rewrite the function given to us into the simpler form by using the concept of partial fractions. We rewrote it as a upon x minus 1 plus b upon x plus 5 plus c upon 2x minus 1. Again, simplifying this equation number 1, we got equation number 2, wherein we can substitute x is equal to minus 5, the component a will vanish, also component c will also vanish by substituting x equal to minus 5. Substituting x is equal to 1, component b will vanish and component c will also vanish. So we got x is equal to minus 5 and x is equal to 1. The third value for x for which the component will vanish is x is equal to 1 by 2. So we got three values, the 1 minus 5 and 1 by 2 as three values. Now we again use the same strategy to solve equation number 2 by substituting different values, wherein say firstly we substitute the value x is equal to 1. Substituting the value x is equal to 1 in equation number 2, you will get the value of a. Now substituting x is equal to 1 over here and here, you will get a 1 equal to a into 6 into 1 plus 0 plus 0. So that means a is equal to 1 by 6, which is our first value. Similarly, for value minus 5, you will get b is equal to minus 5 over 66. Similarly, for x is equal to 1 by 2, you will get c is equal to minus 2 by 11. Now, substituting a is equal to 1 by 6, b is equal to minus 5 by 66, c is equal to minus 2 by 11 in equation number 1, that is a, b and c, you will get the integral of this transformed into integral of this, and which is integral of this, which is written in this format, equation number 3. Now again you can see these expressions are following the formula integral of f dash x upon fx dx, that is equal to log of fx. So we are getting log of x minus 1, 1 by 6 log of x minus 1 minus 5 by 66 log of x plus 5 minus 2 by 11 log of 2x minus 1 plus c. So this is the required solution. Now there is one more technique, that is integration by parts. Now integration by parts is actually in the form of words. You can express is that first function into integral of second function. So we are given an expression integral of ux into vx into dx. So this is a first function and this is a second function in the given integral. Then this can be expressed as first function into integral of second function minus integral of derivative of first function into integral of second function. So this is what is written over here, that integral of ux into vx dx is equal to ux into integral of vx dx minus integral of derivative of first function into integral of second function. So, in words you can write first function into integral of second function minus integral of derivative of first function into integral of second function. And but how to choose which function can be first and which function can be second? In that case, we are supposed to follow the rule which is I late. I means inverse, L means logarithm, A means algebraic, T means trigonometric, and E means exponent. So, using this terminology, we can follow the rule I late. So, if an expression say given to us say x into e to the power x. So, this is algebraic expression and this is exponential expression. So, we are given two. So, algebraic should be considered before the exponent. So, first function will be x and second function will be exponential function. So, in the expression ux vx, which is x into e to the power x, the first function is your x and the second function is your e to the power x. So, we are supposed to follow integration by parts by applying this formula, and wherein this integral x into e to the power x dx will be transformed first function, that is x, into integral of second function. So, integral of e to the power x is ex only, minus integral of derivative of first function. So, derivative of x to be found and into integral of second function. So, integral of e to the power x, which is e to the power x. So, you got the expression integral of x into e to the power x dx can be rewritten as x into e to the power x minus integral of ddx of x into e to the power x dx. So, ddx of x is nothing but your 1, because ddx of x to the power n is equal to n x to the power n minus 1. So, this will turn out to be 1 and you will get x into e to the power x minus integral of 1 into e to the power x dx, and which is again but e to the power x. So, the final solution is x into e to the power x minus e to the power x plus c. So, this is what the final solution is. So, we understood that in integration by parts we are supposed to follow the formula I late, wherein I is inverse, L is logarithm, A is algebraic, T is trigonometric and E is exponential. We can solve, say for the better understanding, one more numerical is there, that we are going to solve x into log x dx. Now, again I late, so this is algebraic function and this is logarithmic. So, logarithmic appears first and algebraic appears second. So, this will be taken as second function and this will be taken as first function. So, you can write this as first function as it is, which is log x, into integral of second function. So, integral of x is x square by 2 minus integral of derivative of first function. So, integral of derivative of first function is to be determined and then integral of second function. So, this will be simplified to this expression by applying just the simple formulas, and you will find that it turns out to be 1 over 2 x square log x minus 1 by 4 x square plus c. So, in this session we understood what is integration by substitution, integration by parts, how to perform the integration of the rational function. We had also understood about all the different cases and solved ample number of numericals for your better understanding. Again, it is advised that try to attempt more and more numerical given in your self-learning material, and you will get better grasp onto the subject. Thank you very much.